That. There we go. And 27. All right, good morning, class. So today is review for your exam on Monday. Any questions about anything before we get started? Are there any requests? Not. See this 8.2 module 10, the homework's still open, so I figured we could do some of these problems. Might be helpful to y'all. Y'all can hear me, right?
Yes, we can hear you.
All right, cool. See, this is number 5 from the homework. Let's see, they give us A, they give us beta, and they give us C. This is a side angle side situation. They want the area. We could use Heron's area formula, which would be the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C over 2, half the perimeter. All right, puppy dog, get down. Go on, go play. Go on. You can sit in my lap later. All right. Okay. And this would be great if we had A, B, and C, but we only have A and C. But since we have beta, we can easily find B, because B squared is A squared plus C squared minus 2AC cosine beta from the law of cosines. All right, so B is the square root of that. So once you know B and we have A and C, we just plug them in here, boop. And then you have the area. Any questions about that? We know A, we know C, and we know beta. There's your map. All right, let's look at another one. So let's see what number 5. There we go. Number 6. Same thing here. This is easy. You don't even need to use the law of cosines. If you know A, B, and C, you just plug them into Heron's area formula. That one's easy. Number 7 here. Mm-hmm. 4 decimal places. Let's see here. Surveyor gives you A, B, and an angle. Find the distance across the lake. We need to find C. We have A, we have B, we have gamma. Well, if we have these, we can figure that out with the law of cosine. C squared, A squared plus B squared minus 2AB cosine gamma. We know what A is. We know what B is. And we know what gamma is. C is just the square root of that. Just plug in the numbers. Bump. There's your map. Problem done. Any questions about this one? Okay, let's look at another one. 7, let's look at number 8. All right. A and a B. Find the distance between the two cities. We need to know this. Well, that's A and B. We're going to call this C again. And this is easy because we know A, B, and gamma. Right? So C squared is A squared plus B squared minus 2AB cosine gamma. Right? C and the gamma go together. These are the two sides opposite that side. Yeah, so C is the square root of this stuff. And we know what A is, we know what B is, and we know what gamma is. Boom, just plug them in. There we go. Perimeter equals help numbers. I don't know what kind of units help numbers are, but we can find the perimeter. All right, this circle has a radius of 8. So that's 8. We want to know the perimeter. There's 8 sides. Let's see if I call this this link here A. The perimeter is 8A. This is 8. We'll call this alpha. Well, all the way around is 360 degrees, and every one of these is the same, right? Alpha, alpha, alpha. So alpha is 180 divided by 8, which is 45. Get this out of the way. So all I need to do is find A. I know what alpha is. If I call this B and I call this C, right? This is 45. Since I know everything over here, I could figure out what A is. A squared equals B squared plus C squared minus 2BC cosine alpha. I know what alpha is. B and C are both 8, right? And so A is the square root of all that. So that'll give us A, right? Yeah, if you don't think about it, like all the way around is 360 degrees. So divide it by 8. So once you know what A is, multiply it by 8, and you have the perimeter of the octagon. Where was that one? That was 9. Look at 10. This one is tricky, Trickerton. We have this tower. We have it's located on a hill. It's 34. There's incline 34 degrees. I don't know. Let's see. I think I did this one wrong last time for the last class. When I looked at this, I saw, well, this is a right angle because the tower goes straight up, right? And if we know A and we know B, we could just get C by the Pythagorean theorem, right? But I totally did it wrong. Let's see, because this is not a right angle because this thing is on a hill, right? All right, so it's actually uphill. So let's see. If this is 34 degrees, let's see, line straight up. How do we figure out what this angle here is? 90 minus 34, right? Yeah, because this is 90. Like this angle has to be the same as this angle. So that angle, again, is 90 minus 34, right? So if we call this what? If I call this alpha, we'll call this B, we'll call this C, and this side is A, right? Alpha is 90 minus 34, which is what? 56, right? Yeah. So this is 56 degrees. So now we know these three. We have to use the law of cosine. A squared, B squared plus C squared minus 2BC cosine alpha. So A is the square root of that. And we know what B is. We know what C is. And we know what alpha is. And then we're done. Okay. Any questions about that one?
No.
Okay. Let's see. There's also a writing assignment due. Let's see if we can work some of these. Look at number 6 here. All right, if possible, find all angle measures of the triangle shown below. Well, we know all three sides here. This is A, this is C, this is B. Let's write them down over here. A is 8, B is 14, C is 19. Okay, we need alpha, we need beta, we need gamma. So this is a side situation. We can't use the law of sines, right? We only have 2 out of 4 pieces of information. 2 out of 4, 2 out of 4. So this is going to be a law of cosine situation. Let's see if we aim for alpha here. Oh, we'd have to use this. We know A, B, and C, we can go for alpha. So if I did A squared equals B squared plus C squared minus 2BC cosine alpha, alpha would be cosine inverse B squared plus C squared minus A squared over 2BC. Which would be 14 squared plus 19 squared minus 8 squared over 2BC. And let's see if I can plug this into my calculator without messing it up. Okay. Arc cosine of 14 squared plus 19 squared minus 8 squared divided by 2 times 14 times 19, and then convert to degrees. All right, assuming I typed this in correctly, I'm getting 22.07 or 08 degrees if we go with 2 decimal places. Okay, so now that I got alpha, I have 3 out of 4, I can get beta. So law of cosines, law of sines. Sine beta over B would equal sine alpha over A. So beta is sine inverse B sine alpha over A. All right, just move the A over here and then take sine inverse, the B over there and then take sine inverse of both sides. So this would be sine inverse 14. What is alpha? 22.08 degrees. And A is 8. Let's try to see if I can plug this in. Arc sine of 14 sine of 22.08 divided by 8, and then convert to degrees. I'm getting 41.13 degrees. All right, so now that I know 2 out of 3, I can get the third, gamma, 180 minus alpha minus beta. So 180 minus 22.08 minus 41.13. I'm getting 116.06 degrees. And done. So law of cosines and then law of sines. We do this and then we do that. Number 1, sure. Derive the law of sines. All right, this was the law of sines section. The first thing they do in the book is derive it. If we call this h, and if this is x, that means that this would be c minus x, because all the way across is c, right? So if we, let's say this would be alpha, this would be beta. So if we look at this right triangle, we could, since we're trying to get law of sines, let's use sine here. Sine of alpha is opposite over hypotenuse. And we do the same thing over here with beta. We'd say sine beta is opposite over hypotenuse. So this says h is b sine alpha. This says h is a sine beta. Well, h is equal to h. So b sine alpha is equal to a sine beta. Or sine alpha over a equal to sine beta over b. And since a, b, and c are arbitrarily labeled, we could have called any one of these a and then the other two b and c, right? There's no special side to a regular old triangle, right? A right triangle has a special side, the hypotenuse. But this is not special at all. None of these three sides. I could have called this A and this one B and then that one C, right? Or I could have called this one A and this one B and that one C. It wouldn't have mattered. So just by relabeling, we get the other three versions of this, all right? Right, because you have really three. That's sine gamma over C. And you also have this one. There's three equations, right? Which we would simply write as, that's how we would write it, right? This is actually three different equations, these three. Okay, and so you just have to prove one, and then the others, so you're just relabeling the sides. All right, what do they want to do? Try writing the length, the height in two different ways. Yeah, that's what we did. We wrote it in two different ways. All right, the word derive. Yeah, you want to be able to derive your identities. That's what we've been doing, right? The word derive, it means use definitions like these. Those were definitions, right? And then we came up with an identity, right? So that's what we did. We derived it. Let me do number 6 here. Oh, we just did 6, right? We need to do number 5. Let's do number 5. All right, so let's see. They say C. Where's side C? If that's point A, that's point B. This is point C. So over here, this is C. All right. This is 35 degrees. What is it? C. B is 6. So this is B. So if this is fixed, let's see. If this angle is fixed and this side is fixed and B is fixed, you could either have this triangle or you could have this triangle. The side B being 6, you can either prop it this way or that way, right? So you either have this little triangle or you have the bigger triangle. So this is the ambiguous case, right? Um, so there are two possible triangles that satisfy these conditions. Let's write down what we have. This would be A2. This would be A1. This would be gamma 1. This would be gamma 2. B is the same either way. This would be alpha 1. This would be alpha 2. So this is triangle 2, and this is triangle 1. But let's write down what we have. We have A, alpha, B, beta, C is 8. We don't know gamma. So that's writing it down generically. So there's going to be two triangles that work out. They've already told us that. I call this 1, 1, 1, 2, 2, 2. All right, let's see what we can do here. Looking at this, I have 3 out of 4 pieces of information, so I can get what gamma is here. I would say sine gamma over C is equal to sine beta over B. So therefore, gamma would be sine inverse of C sine beta over B. Actually, let me do it this way. Call this gamma 1. C is 8. Beta is 35 degrees. And B is 6. And whatever this is, I'll type it into the calculator here. Arc sine of 8 and sine 35 divided by 6 convert to degrees. I'm getting 49.89 degrees. That's somewhere right in here. All right. Now that's one angle. The other one would be 180 minus the first one. The other one is this guy, right? So it's 180 minus gamma 1, right? There's gamma 1. This is our gamma 2. Oh, let's see. 180 minus 49.89. 130.11 degrees. Let's write these up here. 49.89 or 130.11. You can see over here, this is the 49.89, but if we prop B this way, we get gamma to be 130.11. Okay, so these are the two different triangles. Now that we have 2 out of 3, right? Alpha 1 would just be 180 minus beta minus gamma 1. Of course, alpha 2 would be 180 minus beta minus gamma 2. We could figure those out pretty easily. 180 minus 35 minus 49.89 is 95.11. And now for alpha 2, 180 minus 35 minus 130.11 is 14.89 degrees. See how alpha 2 here is small, right? But alpha 1 is bigger, that's 95 degrees. All right, now we just need to figure out our A's. We have 3 out of 4 pieces of information. We can use the law of sines, right? Right, sine alpha 1 over A1 equal to sine beta over B. Now I should write it upside down. Let's write it upside down. A1 over sine alpha 1 is B over sine beta. So A1 is B sine alpha 1 over sine beta. B is 6. Alpha 1 is 95.11 degrees. Beta is 35. And let's see here. Plugging that in, we have 6 times sine of 95.11 divided by sine of 35. And I'm getting 10.42. All right. And then all we need now is A2. We use the law of sines. We have 3 out of 4. So it looks just like this. Instead of A1, A2. Whatever A2 is 14.89. I can change that in my calculator here. 14.89. 2.69. Right, A2 is this little bitty number, right? And there you have it. Any questions about this one?
No.
All right. See what else we could do. Let's look at another one then. Look at number 3. And we seem to talk a whole lot in that one. Suppose that we are given the lengths of sides AC and BC and the measure of the angle. Okay, we better draw a picture here, right? Let's call this point A, call this point B, call this point C. This would be side A, side B, side C. There's our alpha, there's our beta, there's our gamma. All right, so what do they say? We are given the lengths of sides A to C. So I'm going to make them red. The side from A to C is B. So we know B, and they say B to C. That's over here. So they're saying that we know A. And the measure of angle C. Well, angle C we've called gamma. Can you determine from how many other measurements of triangle ABC, sides and lengths, can you determine? We have 3 out of 6, right? There's 3 sides, 3 angles. If we have 3, we can solve the whole triangle. All right? All 6. All right? How? Well, C is going to be the square root A squared plus B squared minus 2BC cosine gamma, right? This is all known. Boop. That's all known, right? So that'll give us C. So I'm going to put blue as the stuff we can figure out. Boop. That's how we figure it out. Red is the given stuff, okay? So now that we know 3 sides, we can do the law of sines here. We could be like, let's say we wanted, since we have gamma, we can figure out beta, right? We could be like, well, sine beta over B equal to sine gamma over C. So beta is sine inverse B sine gamma over C. We already said we could figure that out. B and gamma are given. So now we know what beta is, right? Well, since we have beta and gamma, we can find alpha. Alpha would be 180 minus beta minus gamma. Gamma is given. Beta we figured out. Therefore, we now know alpha. That's the whole triangle, isn't it? Yeah. So there's your formulas. Yeah, anytime you have 3 pieces out of the 6, you can solve the triangle. What was that? Oh, that was number 3. Number 4 is going to be similar. In triangle ABC, all right, we're given 2 angles and a side. Call this A, B, C, A, B, C, alpha, beta, gamma. All right, so we see that B is given. Gamma is given. C is given. So this is a side angle. or an angle side, right? Angle side. Now if we write these down, let's see. A, we don't know. Beta's 45. Dang it. Beta still. Alpha, we don't know. B, we don't know. C is 5. And gamma is 95 degrees. So if we look at this, we have 3 out of 4 pieces of information. So we can find B, right? B over sine beta is C over sine gamma. So B is C sine beta over sine gamma. Okay. So again, they don't want you to actually solve. They just say how many can you find? We can find all 6. Right? They've given us 3 pieces of information. If you have 3, you can find out all 6. Right? So just plug in the numbers. That's how you would get B. So let's see. These are given. This is how you find B. Boop. Right? Alpha would be 180 minus beta minus gamma. And then A, we could use the law of sines. Right? We say A over sine alpha is equal to C over sine gamma. So A would be C sine alpha over sine gamma, right? And we already know what C is. Alpha is 180 minus beta minus gamma. And gamma is given, so that's what A is. Everything else is just plugging it into your calculator. Any questions about that one? Okay. Let's see, we've done. What happens when you use triangle in which measure of angle is 90? Number 2 here, if C is 90 degrees, then you just have a right triangle. It gives you the Pythagorean theorem. Right? So if we have, right now, they're doing C is 90 degrees. So let's see. Call this A, call this B. Make this a little bigger. So B, A, B. We did that H thing, and they call this X. So this over here would be C minus X. So what happens? Well, one, we can use the Pythagorean theorem, but we still do it the other way. What was it? Sine alpha was H, right? The opposite over hypotenuse. And then the other triangle over here, we could say sine beta is H over A. So H is B sine alpha. H is A sine beta. So these have to be equal. So what happens when C is 90 degrees? Well, we turned a right triangle into 2 right triangles. If that's the case, we can always say that A squared plus B squared is equal to C squared, right? So we could say B is the square root of A squared minus C squared. We could plug that in right there. So the law of sine said A over sine alpha is B over sine beta. But I could replace B here with the square root of A squared minus C squared. I'm not sure what they're trying to get at here, but I mean, if that's a 90-degree, then you just have a right triangle. I don't know what they want you to show. I mean, ultimately, that's what you have. A squared plus B squared equals C squared. And what else do we know? If this is 90, then we also know that beta is 90 minus alpha, right? Because this is 90, so these have to add up to 90. So let's see. We left that as B. I could write this as 90 minus alpha. But this would just be cosine alpha by our cofunction identity, right? So, I mean, these are the two things that we know. If that's a right triangle, we can automatically deduce those two things. I'm not sure what else they want us to show. I mean, those are the two important things. If C is a 90-degree angle. I guess that's the whole writing assignment, isn't it? All right. Well, y'all have any more questions? We can do a homework problem from another. Let's see, assignment. Let's see here. Law of cosines. We can go back to law of sines here. Put some problems out of here. I don't know if we've done these or not. All right. Brian's house is on a corner lot. Find the area of the front yard if we know what B and C are and what A is. Okay. Well, we could use Heron's area formula. If I call this side A, right? Here's alpha. We know alpha, we know B, and we know C. We can figure out what A is. A is the square root B squared plus C squared minus 2BC cosine alpha. Right? We know what B is. We know what C is. And we know what alpha is. Once we have A, S is A plus B plus C over 2. And the area is S times S minus A times S minus B times S minus C. Heron's area formula. And that's it. This is exactly the same thing as the last one. Find the area of the triangle with the given measurements. So let's see. If we know A and C and beta, B is the square root of A squared plus C squared minus 2AC cosine beta. Those are all given, AC and beta. Once we know what B is, S is A plus B plus C over 2. And the area is the square root of S times S minus A times S minus B times S minus C. You got B, plug it in here. You already have A and C. A and C. You just plug them in. Heron's area formula. 10 on 7.6. Let's see here. Homework sets. 7.6 over 10. Look at 6. Number 6 from the law of signs. Yeah, well, we got time for one of these. Let's see here. I'm happy to stay late to work more problems if y'all want. The volume of air in the lungs is given by this equation. So V is for volume. T is the time in minutes. All right. Okay. What is the maximum possible volume of air in the athlete's lungs? Okay, so this is all, sign is always between -1 and 1, right? So volume here is going to be a maximum when sign is 1, right? That's when you're going to get 311 plus 763. That's going to be your max volume. Your max volume is 311 plus 763, right? The minimum volume occurs when sign is equal to -1, right? Because then you're going to get 763 minus 311, right? This would be negative 311 plus 763. This is because sign is always between -1 and 1, right? It's going to give you the max, it's going to give you the min. How many breaths does the athlete take per minute? Okay. Well, let's think about this. You'd have to go from, let's see, if we plug in 0 here, that's going to put us, all right, let's see. If we start off at a minimum, let's see, sign, yeah, something like that. So we go from a minimum to a minimum. So we have to figure out the period, like what is the time that it takes to have one breath, right? Well, the period, right? The period, or the time it takes to make one breath was what? 2 pi over omega. And hold on. Time is in minutes. Okay. So this is going to be 2 pi over 99 pi. This is 2 over 99. And this is in minutes. And so since this is a period, this is per minute. How can I say this? So at time 0, this would be 2 over 99. I don't know, that doesn't look right. Yeah, I mean, the period is 2 pi divided by omega. Omega is 99 pi. This is just a really small number, right? That you have to be breathing really fast, right? Let's see. 2 divided by 99. This is approximately 0.02 minutes. That's a very short time for a whole breath. Right? Because we want to go from, let's see, no air, he takes a breath, exhales, and that's not even a tenth of a minute. Well, I guess so. if I converted this to seconds, right? I'm thinking seconds. 0.02 minutes, if I wanted to convert this to seconds, would be, let's see, 0.02 minutes. I'll get rid of minutes and I want seconds. There's 60 seconds in a minute. So I just multiply that by 60. Yeah, that makes sense. 1.21 seconds per breath, right? So we have 0.0, if they want it in per minute, we have 1 breath for every 0.02 minutes, okay? Because the period is 0.02 minutes. But they want us to know what breaths per minute this is. We already have breaths per minute. That's the right units. So we just take 1 and divide by 0.02. 1 divided by 0.02, 020202. And we're going to get 50 breaths per minute. Really, this number was 0.020202. All right, I rounded. But if you type in the whole thing, you get 50. There's going to be 50 breaths per minute. And let's see, I want to see 6 from law of sines. Is that from the homework, Andre? Talking about number 6 from the law of sines. Law of sines. Let's see, number 6. And we're out of time, so y'all welcome to go. But I'll finish this one up for y'all. For those of y'all who want to hang around. And if you have another class, I don't want you missing. Frank and Mary set sail from the same point. Frank is sailing in the direction, what is that? That's 3 degrees east. Mary is sailing in the direction south 9 degrees west. Okay, crap. Let's see. How can we draw this picture? The south, going southeast. So let's see. That's southeast, right? They're saying south 3 degrees. That's what that is, I think, right? South 3 degrees, and we're going, no, that's west. We need to be going east. Yeah, we're going east and south 3 degrees. Yeah. So that's Frank. Make this bigger here. There's Frank. Mary is sailing in the direction south 9 degrees west. So they start here. Frank is going southwest at 9 degrees. So here's Mary. All right. After 10 hours, Mary, who's Mary? Here's Mary. This is Mary's triangle. After 10 hours, Mary was 7 miles due west of Frank. What? Mary, okay, so here's Mary. Let me put a dot. And here's Frank. Mary was 7 miles west of Frank. So let me exaggerate this a little bit. I don't know what this would look like, but Right. So I'm thinking we need this 7 miles, right? Because they're from east to west. Okay. How far had Mary sailed? Oh, Jesus Christ. So what do we have here? This is 7. Oh. We need to figure out what this is, right? How far has Mary sailed? It's gonna take me a while. Yes. That means we project upwards here. From here to here is 7. Okay. What else could we figure out? We could figure out this angle. So all the way from here to here is 180. So if we subtract 12, 180 minus 12 would be 168. We want to know this length. Well, let's see, we have a right triangle here. Move this over. We want to know that. I shouldn't do this in red. I'm going to make this blue. Let's see, what can we do here? We want to figure out what that is. Okay, well, this is 9 degrees. That's 90. We can figure out this angle, right? Because this is a right triangle in here. So this angle here has to be 90 minus 9, which is 81 degrees. So let's blow up that triangle here. Right? I'm just taking this triangle and drawing it bigger. This is 81. This is 9. We need to figure out what this is. We don't have enough information here, do we? We know that this is 7. We need to get that information involved somehow. If I call this y, then this has to be 7 minus y. Oh, this has to be x as well, because they both started right here and they both sailed at the same amount of time. So if we're assuming, right, assume they sail at the same speed. If we then these distances have to be the same, but that doesn't make sense because wind only blows in one direction. And so if they're going in different directions, if they're sailing, they'd be going at different speeds, wouldn't they? I mean, I don't know much about sailing, but I kind of understand physics. But I guess if we have to make that assumption, because then we can look at this triangle over here as well. If that's 3 degrees, then this has to be 87 degrees. So we have two variables here, an x and a y. If we get two equations with two unknowns, we can solve for x and y. We're trying to figure out what x is. Mary is sailing 10 hours. I mean, that's all we know is that Mary is 7 miles west of Frank. So here's Frank. Now that distance has to be 7. So I don't know. The only way I can see that we do this is if we assume that these links in the red are the same. We assume that they're selling at the same speed. Because we want to find X. So if we use the right triangle over here, we could say the X is a hypotenuse. Uh, we have X and Y. This is a hypotenuse. And pick an angle. Let's see. If I use the 9 degrees, this would be adjacent over hypotenuse. I could say cosine of 9 is adjacent over hypotenuse. And then the triangle on the right, I could say the x of the hypotenuse, I could say cosine of 3 degrees is adjacent over hypotenuse. So now we have two equations with two unknowns, and we can solve for x, right? This one says that x is y over cosine of 9 degrees. And this one here says that, let's see, 7 minus y would be x cosine of 3 degrees. So y would be, let's subtract 7. This would be 7 minus x cosine of 3 degrees. Right? Subtract. So I could substitute that in up here. If I did that, these two tell me that x is 7 minus x cosine 3 degrees over cosine 9 degrees. I got to get my x's together. So I would say, okay, x cosine 9 equals 7 minus x cosine of 3. So x times cosine of 9 plus cosine of 3. So I'm moving this to this side, factoring out the x. I'm left with 7. X is 7 divided by this stuff. That's what I'm getting for x. What is this? This is the homework. So let's try it out. See if we get it right. 7 divided by cosine of 9 plus cosine of 3. I'm getting 3.52. 3.52. 3.52. Damn it. Oh, we need 4 decimal places. Okay. 3.5241. Still wrong, huh? Well, I don't know. This problem sucks. Let's see, what else could we assume here? Assume they're at the same speed. That means that this is the same as this. I think my diagram's correct. Mary was 7 miles due west of Frank. Maybe am I reading this right? South 3 degrees east. I don't remember doing stuff like this. South 3 degrees east. So they're going southeast, right? So this is south and east. And we get 3 degrees. South 3 degrees east. Maybe I'm interpreting this wrong. 17 miles, huh? south 9 degrees west. I don't know, maybe I'm interpreting these wrong. I don't know, let's see, southwest. So here we're going south and we're going west, 9 degrees. So this angle is bigger than that one. We have two right triangles. Yeah, this is odd. I mean, maybe you can't make this assumption, right? I mean, if you make that assumption, I'm pretty sure what I did is correct, unless I did something wrong with my algebra. Right, so I guess we can't assume that. If we can't assume that, then these are different values. If those are different values, I don't know. Let's try drawing another picture here. So they start somewhere. One goes south west, wait, southeast at 3 degrees. So we'll do, of course, that's exaggerated. The other one goes southwest at 9 degrees. And after 10 hours, we have, here is Mary. No, this one's Mary. This one's Frank, right? Mary is selling, no, this one is Mary. This guy's Frank, okay. And we can't, if we don't assume that they're going at the same speed, we know this is 7, okay? That's all that's given, right? Right, that's the whole problem. So we have two right triangles. So if I call this x, this has to be 7 minus x. No, I shouldn't call that x because we want to call this x. X is what we're trying to figure out, how the distance sheet. So let's call these y. I call this y, and this is 7 minus y. If we don't assume that these are the same length, I don't know how you can do this problem. I guess I could figure out what this is, but this and this are going to be different. I don't know. I think we have to assume that these are the same length. We just have to. Maybe I did something wrong here. If we use 9 degrees, let's see. This is the adjacent, this is the hypotenuse. So I do cosine of 9 adjacent over hypotenuse. In the other triangle, I do cosine of 3 is adjacent over hypotenuse, right? So y is x cosine of 9 degrees. So this is 7 minus x cosine of 9 all over x. So I'd have x cosine of 3 degrees equals 7 minus x cosine of 9 degrees. So x cosine of 3 plus x cosine of 9 equals 7. So x would be 7 divided by cosine of 3 plus cosine of 9, right? That's what I got last time. Yeah, I don't know. If they're not letting us assume that these are the same, I mean, cosine, I'm doing this right, cosine is adjacent over hypotenuse. Yeah, I typed it in right. Yeah, I don't know. apparently we can't assume this. So if we can't do that, that means we can't do this. Right? Maybe we could use a, oh, I got an idea. What if we looked at this triangle? See, this would be 180 minus 12, which was what, 168? If we can get some of the information in here, right? Like, we called this X. Maybe we can get, we'd have to get this 7 information involved in this other triangle. Like we get information down here. This is the law of sines, right? Section. So maybe we should focus on this and try to use law of sines. If we can get some of these sides here, this is 7, right triangle. Let's see. Okay, we can get this angle because, let's see, that's 99, right? So this has to be 90 minus 9, which would be 81 degrees. If that's 81, oh hell, then we could figure that out. This whole thing would have to be 9 degrees. So if this whole thing is 9 degrees, and we just want this little bit, this whole thing is 9. We'd have to know what this is though. Fart. Yeah, somehow we have to get the law of sines involved. I think we have to focus on this triangle here. We know that this would be 87 degrees. So we need to figure out what these angles are so we can get these 3 these 3 angles. I don't know, I'll ask one of the other bosses. This one, I'm sure it's easier than it seems, right? There has to be something that I'm missing here. I'll have to look at it. I don't want to waste y'all's time. Well, let's see, what problem is this? Is number 6. Yeah, 6 from the law of sines. Yeah, I'll look into that. We'll check it out. I guess after the exam. All right. All right. Sorry about that, y'all. I just don't know. Yeah, I mean, some of these problems are hard, you know. Some are easy. Sometimes the easy ones seem hard. Sometimes the hard ones are easy, but yeah, this one's definitely, I don't know. I just don't know. Y'all got me stumped. Guess I'll be working on this today. All right. Y'all study up for your exam and good luck, everybody. Have a good weekend. Oh, have a good, it's Halloween's on Monday, right? We get to look forward to that. All right, bye, everybody.